You are, technically speaking, on the path to becoming a crab. Not anytime soon, of course, but strange as it sounds, this idea is rooted in real science, and it's one of the weirdest evolutionary patterns still happening on Earth today. Across the animal kingdom, countless creatures that were never crabs to begin with have slowly transformed into crab-like forms. Look closely at these animals. This isn't a crab. That isn't one either. In fact, none of what you're seeing right now are true crabs at all. Yet over millions of years, they've all gradually shifted in the same direction, ending up looking uncannily crab-like. This pattern has been studied so extensively that scientists gave it an official name, carcinization. Based on its Latin roots, the word literally translates to crab-making. It describes the repeated tendency of evolution to reshape different animals into something that resembles a crab. It sounds absurd, and honestly, it kind of is. But once you start paying attention to nature, you realize this keeps happening over and over again. Some species crabified tens of millions of years apart. Others did it in completely separate oceans. Some weren't even closely related in any meaningful way. And yet, they all ended up with the same general design. So that raises a big question. Why does evolution keep choosing this shape? Why does the crab form seem so effective? And what's stopping humans from eventually evolving into crabs too? Is every evolutionary road destined to end with claws and a sideways walk? Online, this whole crabification idea has turned into a running joke, spawning hundreds of memes that treat crabs as the final, perfect form of life. And weirdly enough, science kind of agrees. From an evolutionary standpoint, this body plan is incredibly efficient, almost optimal. But how do we actually know that? The answer lies in a powerful concept known as convergent evolution. This is when completely different organisms face similar environmental challenges and, despite having separate evolutionary histories, independently develop the same traits to survive. If you've seen our video on giant squids, you already know how this works. Two completely different squid species, with separate evolutionary histories, both grew to enormous sizes. Not because they were related, but because being massive gave each of them a survival advantage. Bigger worked, so bigger evolved. Now apply that same logic here. Why crabs? And why does this keep happening so often? To answer that, we first need to define what crab-like actually means. Because looking like a crab doesn't automatically make something a true crab. In fact, most of the animals we casually call crabs aren't real crabs at all. They're evolutionary lookalikes, species that independently arrived at the same design. A crab-shaped body is typically wide and flattened, which keeps the center of gravity low. That makes the animal incredibly stable, especially in rough environments. This shape also allows it to slide under rocks, wedge itself into narrow crevices, and stay grounded instead of being rolled over by waves or attacked from below. And trust me, getting flipped upside down in the ocean is not a good situation to be in. Of course, crab-like bodies also come with a hard shell. But that shell isn't just protective armor. It turns the entire animal into a compact, armored unit, basically a living tank. When your whole body acts as a shield, you're far more likely to survive than animals with long, exposed segments like shrimp or lobsters. Crabs also have short, muscular legs that give them precise control over movement. That's why they can move like this. Okay, not that. Like this. They're especially good at moving sideways, which lets them dodge threats while still keeping their eyes and claws facing the danger. It's a perfect defensive strategy. But this brings up an interesting question. If the crab design is so effective, why didn't everything evolve into lobsters instead? Lobsters are tough, well-armored, and clearly successful. They've survived for millions of years too. So why don't we see lobsterization happening everywhere? The answer is simple: the lobster body plan is far less flexible. Lobsters have long, segmented bodies with extended tails, and that structure severely limits how much evolution can reshape them. That layout locks them into a specific form, making drastic changes much harder to pull off. You simply can't flatten a lobster without destroying how it works. The second you try to fold that long, powerful tail underneath the body, like crabs do, the entire system breaks down. The anatomy just isn't built for it. Crabs, meanwhile, start off with a compact layout that's incredibly flexible. Their basic design is easy for evolution to adjust. The body can become wider or shorter, the shell can thicken, the legs can shift position, and none of this interferes with how the animal moves. Once a species reaches a crab-like form, it tends to stay that way. Very few ever evolve back into a stretched-out shape. Reversing that process would be extremely complicated. To go from crab back to lobster, an animal would need to lengthen its abdomen again, rebuild its muscle structure, redesign its tail fins, and reorganize the entire body plan from the inside out. Those kinds of changes are far more difficult than simply shortening the body and tucking the tail underneath. That's why carcinization is evolutionarily cheap. Lobsterization, on the other hand, is incredibly expensive. So which animal was the very first crab to become a crab? Technically, the earliest true crabs, known as Brachyura, appeared more than 200 million years ago, long before dinosaurs ever walked the earth. But here's the twist, they weren't the only ones doing it. Around that same period, several other crustaceans, completely outside the true crab family, also began evolving into crab-shaped forms. We don't label Brachyura as real crabs because they were somehow more advanced or biologically superior. The main reason is much simpler. They were just the one scientists identified first. Back when early biologists were classifying animals, they had no understanding of genetics or evolutionary ancestry. Everything was grouped based purely on appearance. At the time, scientists were classifying animals based entirely on how they looked. So creatures in the Brachyura group, those with wide, flattened bodies, a tucked-under tail, and a sideways walking style, were labeled as true crabs. In a sense, these became the first animals we officially recognized as crabs. And yes, calling them real crabs sounds a bit silly and repetitive, but it highlights something important. They're included in carcinization too. They didn't invent the crab design themselves. We simply decided that their version of it would be the standard. They became the reference point, the animals we crowned as the official crabs. So if those are the real ones, what about the crabs that aren't actually crabs? The most famous imposters are king crabs. Despite how similar they look, king crabs aren't closely related to true crabs at all. Genetically, they're oversized hermit crabs. Their ancestors once lived the classic hermit lifestyle, carrying borrowed snail shells on their backs, just like the tiny hermit crabs you see along beaches today. Over millions of years, though, that strategy changed. Their bodies hardened, external shells became unnecessary, and they stopped swapping homes. Their shape gradually flattened, widened, and shifted into a crab-like form because that design simply worked better. Even though king crabs resemble true crabs far more than they resemble hermit crabs on the outside, their evolutionary roots are completely different. They come from separate branches of the crustacean family tree. Their last shared ancestor wasn't a crab at all. It was some ancient, primitive crustacean that lived hundreds of millions of years ago. We can't know exactly what it looked like, but one thing is certain. It didn't look anything like a crab. It's actually pretty telling that people who eat king crab and regular crab on a somewhat regular basis can usually tell them apart just by taste. That difference makes sense, because biologically, they aren't the same animal. But king crabs aren't the only creatures that took the crab route. Take porcelain crabs, for example. And yes, at this point you might be wondering, is everything that isn't a crab still somehow called a crab? That confusion isn't accidental. When early explorers and scientists first encountered these animals, anything that looked crab-like was simply named a crab. Those names stuck, even though modern science now understands their evolutionary history far better. Changing names after the fact is surprisingly difficult, even when we know they're misleading. Porcelain crabs belong to the order Anomura, the same group as squat lobsters. In reality, they're extremely similar to those squat lobsters, just with a more compact, crab-shaped appearance. They don't behave like true crabs in combat, and their shells are far more fragile, often cracking easily, almost as if they're actually made of porcelain. Still, imagine stumbling across one of these creatures with no scientific background. Flat body, sideways movement, clawed arms. Who wouldn't immediately call it a crab? And here's where it gets even stranger. Carcinization didn't just happen after crabs existed. We now know that crab-like body plans appeared in ancient species long before true crabs ever evolved in the first place. Fossils like Carcinus and Prosopon show us that carcinization was already happening long before true crabs ever appeared. Over and over again in the fossil record, we see the same familiar design: wide, flattened bodies with tails folded underneath, as if evolution itself keeps returning to the same blueprint. It almost feels like nature can't stop making crabs. But if this body plan is so powerful, that leads to an obvious question. Where are all of those early crab-like creatures now? The reality is, most of them are gone. Many of these early protocrabs are completely extinct. And the reason is simple: they weren't very good at being crabs yet. Some never developed the thick, hardened shells that modern crabs rely on for protection. Others lacked the specialized leg structure needed for that stable, sideways movement that makes crabs so effective. And some were simply unlucky, living in environments that collapsed during massive extinction events, like the asteroid impact that wiped out the dinosaurs. Hard to blame them for that one. But even when those lineages disappeared, the design itself didn't. Evolution rebuilt it again and again. The crab-shaped body isn't a one-time accident, it's a solution that keeps re-emerging because it works. As long as crustaceans exist in environments where this design is useful, crab-like forms will continue to evolve. The crabs we see today are simply the most refined version so far, the best crab designs evolution has managed to produce. So what else could turn into a crab in the future? The unsettling answer is almost anything, given the right conditions. We've already seen numerous animal lineages slowly drift toward the crab shape over time. Some shrimp lineages are even beginning to show the earliest signs of this transformation. Their bodies are slowly flattening, their tails starting to tuck inward, the very first baby steps on the long evolutionary road toward becoming crab-like. That said, this process really only plays out fully within crustaceans. We're not going to wake up one day and see lions sprouting shells and claws. Their bodies are built for entirely different lifestyles. And humans, despite all our evolutionary success, aren't headed toward crabhood either. So yes, you're safe, at least for now. But here's where things get really interesting. Other animals have evolved body shapes that resemble crabs for similar reasons, even though they aren't crustaceans at all. Take stingrays, for example. They aren't crabs in any biological sense. Not even remotely. And yet, their overall shape follows the same basic idea. A broad, flattened body designed for stability. Crabs flatten themselves to stay low, resist strong currents, and hug the seafloor. Stingrays flatten out for a different reason, to glide smoothly through water with minimal resistance. Different lifestyles, same physical logic. So does that mean stingrays are also on the path to becoming crabs? Not quite. What we're seeing here is partial convergent evolution. Similar problems leading to similar solutions. It's not carcinization. It's not stingrayization either. It's just flattening. In the end, everything in evolution is relative. Examples of partial convergent evolution are everywhere, we just don't usually stop to notice them. Take dolphins and sharks, for instance. Biologically, these two animals couldn't be more different. Sharks are ancient fish with skeletons made of cartilage. Dolphins, on the other hand, are warm-blooded mammals. They breathe air, nurse their young, and are actually more closely related to land animals like cows than to anything swimming beside them. And yet, put them next to each other, and they look shockingly similar. Both evolved the same sleek, torpedo-shaped bodies because that design is simply the most efficient way to move through water. If you want to travel fast, remain stable at high speeds, and minimize energy loss, evolution nudges you toward that same streamlined form every time. The rules are set by physics. If an animal's lifestyle keeps it near the ocean floor, the body plan tends to flatten. If it needs to slice through open water, it becomes narrow and pointed. The same principle applies in the air. Birds, bats, insects, even ancient flying reptiles, independently arrived at similar wing designs because flight only allows a small number of shapes that actually work. When the environment limits the options, evolution keeps choosing the same solutions. The environments animals live in only allow a limited number of workable designs. Evolution doesn't have infinite blueprints to choose from. So it's not that everything is slowly turning into a crab, it's that creatures living in certain conditions keep arriving at the same highly effective shape. And we just happen to call that shape a crab. Luckily, or unluckily, most non-crustaceans will never fully crabify. Crustaceans already start with the ideal foundation. Their shells can broaden, their tails can fold underneath, and their legs can rotate sideways without breaking how their bodies function. That flexibility makes the transition possible. Other body plans don't have that luxury. Wings, for example, require extremely specific bone structures and muscle arrangements, which is why only a handful of groups ever manage to evolve true flight. A lion or a lizard simply doesn't have the anatomical starting point to flatten into a crab or grow wings without completely losing the ability to survive. And even if they could, being a crab wouldn't help them in their environment anyway. Carcinization isn't some unavoidable evolutionary fate for all life. It's just a repeated outcome within a specific group of animals that are physically capable of becoming crab-like. As diverse as life on Earth is, evolution doesn't endlessly invent brand new ideas. Instead, it keeps reusing what works. And crustaceans, by their very nature, are built in a way that keeps funneling them toward the crab form again and again. Thanks for watching.